Hello, my name is Andrew Geary, and welcome to Seismic Sound Off, in-depth conversations in applied geophysics. In this episode, we highlight Sergey Fomel's current distinguished lecturer tour, Automating Seismic Data Analysis and Interpretation. Sergey and I dive deep into automatic picking, why humans will always be essential to data analysis and interpretation, the value of this lecture for someone not familiar with programming, and one tip to help anyone succeed as a geophysicist. While Sergey's tour is currently canceled due to COVID-19 coronavirus concerns, there are two upcoming free virtual lectures. The first will take place on April 22nd and the second on May 12th. Please visit seg.org/podcast for all the details. Now for our conversation. So Sergey, if you would just provide a 60-second overview of your current distinguished lecturer tour.
Well, so the topic of the lecture is automation. The lecture has different parts. So I want to give specific examples, and we focus on one particular task in geophysical data analysis that we've been trying to automate, and then how it has applications in different areas, mostly in seismic interpretation. But in addition to that, I talk about the difference between humans and machines, and I want to focus on the human side. And this is for two reasons. One, just because I like to talk about the human experience, and I recall some of the people that I met, and I point out that my age, I am 52 years old, is kind of special in our community because I'm the local minimum in the demographic curve. There are generally less people of my age than older people or younger people. But now the older generation is moving into retirement. So I'm recalling some of the people from the older generation who are no longer with us, and I'm trying to recall lessons that I learned from them, and then I tie it to the topic of the lecture, sort of show the continuity of thought.
So you're bridging the gap there between the new and the past experienced geophysicist.
Right, and I say explicitly that that's one of my purposes in life, is to make sure that we remember and preserve the contributions and the wisdom from the earlier generation.
So you mentioned this in the description of your tour, and you mentioned it in the answer there. What interests you is humans as well. You know, what are two qualities that separate human geophysicists from machines?
Well, I actually mentioned three qualities.
Get a bonus one. That's great.
Right. Well, so what I say is previously, so maybe just a few years ago, we could claim that the human brain is really unique and it can do some tasks that computers could not possibly do. So now we know that this is not true, and that no matter what the task is, we can actually teach a computer to imitate a human. So it's not our individual mental abilities that make us different, but what we do with them collectively. And there's three sort of human traits that I highlight. So one is freedom. So I sort of go into a little bit into philosophy because it's a difficult question in philosophy about the existence of free will. But it's one of the traits that we like to have freedom and the freedom of choice and create new choices when we don't have them. And the other is that we are human because we care about other humans, and that leads to trying to fit in and to stand out from the crowd and to competition. So the second one is competition. And the third one is we care about other humans because we identify with them. And I point out that ECG is one of the ways people connect by having a shared identity. And so the third trait is a sense of community. And I show with, so first I talk about that abstractly, but then I return to it during the lecture to point out places where the three traits, freedom, competition, and community, come together, and then they lead to great achievements.
In reviewing the development of automatic picking algorithms for your lecture, what did you learn that made you excited to share with your audience what you found out?
Well, so the history of automatic picking is fairly long, so we have been trying to automate this for a long time. And I discuss one breakthrough that came by borrowing ideas from medical imaging. And that's actually where I get technical in the lecture, and I even show a piece of code for people who like computer programming to explain how we actually are computing this. And then I show the newest results, and that was joint work with Xinmin Gu, and how he brought deep learning to the same problem, the new developments in artificial intelligence. And the completely new level we get from that in accuracy and in efficiency. And this is usually the part that gets people excited when they see the results and the comparisons.
Ziming Wu, it's interesting that you brought him up. I spoke with him recently on his tour going on, and it's very connected to what you're working on. So this AI and deep learning, they're very hot topics. Why is seismic interpretation such a strong candidate to include this more and better deep learning?
Well, it's certainly not the only area where we can get benefits from deep learning, and we have seen it in many other applications in imaging and inversion and everywhere we do computing. But seismic interpretation is a big part of computing in the industry, computers in general. And when it comes to automation, it's an obvious candidate because the standard practice involves a lot of manual work. So there are many people who spend their working days basically doing manual picking. And we don't want to just get rid of them because many of them have unique expertise and they bring more to it than just image analysis. But we want to make their life easier so they can focus on more creative tasks and maybe leave more simple, straightforward tasks to a computer.
What unique role does automatic picking play in seismic interpretation?
Well, picking occurs in different places. So we pick features in seismic images, and they can be horizons, geobodies like salt bodies or channels, and they can be faults. I show examples with faults, so mostly from Xinming's work, and also some examples of salt picking.
You had mentioned you're kind of bridging the gap with geophysicists, and some people might see artificial intelligence and deep learning, and you mentioned coding, could scare some people away. Who may be reading the description of your lecture for the first time may not realize that this lecture is actually for them and would benefit them to attend.
Well, so far I've given it to many different audiences. Some of them had real experts, and some of them didn't even have too many geophysicists. They were mostly geologists. Because in my lecture, I sort of have different levels. There is a more general philosophical discussion There are more concrete examples, and then there are technical details for people who are really familiar with the subject. I think in every audience it sparked some discussion, and there were some really deep, profound questions that they had to take some time to think about. So I think as a start of a conversation and introducing different people to the subject, so far it has worked very well, and for practically everyone who attends, they can take something out of it.
So it seems like with your experience and expertise in this area and knowing the topic so well that you're able to kind of adjust this lecture almost to the audience that you're giving. Do you have in mind when you're going into these talks that you have, one or two takeaways that you want your attendees to get out no matter who the audience is for the talk you end up giving?
Well, so I thought about that when I prepared the lecture, and I know that some of the previous lecturers had different versions of their talk. So either completely different on different subjects, or same subject, just different version that they offer depending on the audience. And I decided not to do that, so just have everything pretty much the same for different audiences, but to have the lecture that works on different levels. And I want to have my message about the human side and what I call Team Human. It's actually a title of a book, so Team Human versus computers. And that part does not necessarily generate a response from the audience, but it gets them to a different level of thinking. And that helps then talking about more technical details because it creates a framework. And I think that worked for different audiences, so I don't plan to make major changes to the lecture, but I keep tweaking the slides and the words every time I give the lecture.
I'm sure Team Human will really resonate with the audience there. Do you what kind of research breakthroughs do you think are needed for the next evolution of automatic picking?
Well, the picking itself is just a task, and it's sort of easy to explain and to formulate. So I don't think picking itself is really a challenge for the future research. But when it comes to applications like seismic interpretation, I think we'll see a lot more breakthroughs as we move forward. Because right now we are doing simple tasks that are basically image analysis tasks. But the real challenge, and I think this is where this whole field is moving, is to be able to integrate knowledge that is not easily quantifiable. So when experienced geologists do interpretation, they don't just analyze what they see in the image. So they bring with them their knowledge of geology to try to understand the history, the geological history, how different features formed in geologic time, and then they project this understanding to their interpretation. And I think it's entirely possible to capture this sort of knowledge and to produce more geologically meaningful interpretation automatically. But this will be the next level for us to achieve.
I want to just real briefly point your attention to kind of up and coming geophysicists. You're being honored with this distinguished lecturer tour. You've received several awards for your contribution. SEG gave you the J. Clarence Karcher Award. EAGE provided the Conrad Schlumberger Award. What one piece of advice would you offer someone that would like to succeed in your field?
Well, so you need to set your goals. I don't think it's a good goal to if try to get an award. So it's always nice to be recognized for your work, and I certainly appreciate recognition I had, but that's not really the motivation for your career in research. So I think what I learned also from older people when I was younger and the people I mentioned in the lecture, the real driver in research is trying to understand. So sometimes people try to invent something new, and this is also a wrong attitude. So what we really need to do in research is to try to understand how things work and how they can work better. And often, in terms of recognition, people who get recognized are not necessarily those who invented something first, but those who understood what the invention meant. So I remember my physics teacher pointed out that Albert Einstein didn't actually derive the equations for the special theory of relativity, but he was the first one to understand what they really meant and to explain it, so he gets recognition for it. So striving to understand things is more important than trying to invent. And in my career, most of the time when I invented something new, I later discovered that somebody did it before and it was not really a new invention. And in the lecture, I point out how the initial algorithm for automatic picking, I did not actually invent, but I borrowed it almost without change from medical imaging.
It's a good answer. If you could solve just one mystery as a geoscientist, what would you hope to solve?
Well, so right now we have this great tool, so deep learning that came from artificial intelligence has been tried now in many different fields, outside geophysics and in geophysics. But nobody really understands why it works so well. Many people are trying to work on that in mathematics and other fields. And I'm also trying to build my own understanding and sort of take it apart and play around with components. And I think this right now is a mystery, and I think in the future we'll understand it better.
I thank you for your time in between all this travel that you're doing to make time to speak with me today.
Thank you, Andrew.
Thank you for listening to SEG's flagship podcast. Please share this episode with a friend, colleague, or manager that would enjoy hearing this episode. Your recommendation is the single best action you can take on behalf of SEG's podcast. Go to our website at seg.org/podcast to find all our episodes and learn how you can listen to this podcast directly on your phone without downloading an app. Original music by Zach Bridges. This episode was hosted, edited, and produced by me, Andrew Geary. The SEG podcast team is Jennifer Crockett, Allie McGinnis, and Mick Sweeney. Thank you for listening. This is Seismic Sound Off, signaling off.